what we're going to be speaking about today is the atmosphere and the different layers of the atmosphere. So what we have here, the Earth itself is a very massive spherical structure. What you see over here, usually when you're looking at the side, see this little light blue? This represents the atmosphere. Now, there's a whole bunch of layers in there, but we'll start off small as we explain because it's the gases in that atmosphere that allows for many things that we take for granted. The reason why we have water in its liquid form and we could actually live is because of this atmosphere. So the atmosphere is like this big blanket that wraps around the Earth. And what it allows to happen is the heat comes in and it gets trapped by the atmosphere. Too much heat gets trapped, that could be a problem because then some people suggest that means that the climate's warming. But overall, we could call this the greenhouse effect. The greenhouse effect means that the layers of the atmosphere, what it does is it holds in the heat and acts like a big blanket, which we would say would be an insulator. So these other features, and because we have that blanket wrapped around the Earth, which would be those gases, and we'll discuss the exact gases that are in the layers of the atmosphere, it allows for weather. And it's the weather's only in the one layer of the atmosphere. It's called the troposphere. And what we'll do is we'll get into a little bit more discussion about what weather is. But the weather is the temperatures and humidity from a day-to-day basis at a particular time and place. So today, looking outside, looks no clouds, beautiful, nice and dry, low humidity it seems like to me, and slight winds, not too breezy. I mean, I don't know, it's about in the 60s. I'm not sure because I really haven't been out yet. What is the atmosphere? So the atmosphere, and what this means by very thin. So somebody asked me this before. That's what I was trying to describe before. Thin doesn't mean like the air itself, like you feel like thin air as you go up a mountain and it just gets thinner. It's saying that relatively to the size of the Earth, it's like if I'm looking at this diagram, this picture right here, it's about the thickness, less than this pointer, relative to the size of the Earth. And this is a model. You got to remind yourself, this is a model. We also call the atmosphere the air around us. How special is that? So what is the purpose of the atmosphere? When I just mentioned this earlier, it contains oxygen and other gases that are mandatory to live. And because of the specific combination of gases that we have, allows us to have life on Earth as we know it. So it traps energy from the sun. So, like we said before, it's a great insulator. In the beginning of the year, when we did thermal energy, we discussed how air, because the molecules are further apart, why they don't transfer heat that well, and it is a great insulator. And it's also, when you think about it, when it's hot, during the nighttime, it does get cooler. But if you were on another planet without an atmosphere, it would get extremely, extremely cold. Because we have an atmosphere, the temperatures do not vary that greatly from day to day. So it keeps the Earth's surface warm and Earth's water in a liquid form. Key point there, liquid form. We know that from 32 degrees to 212 degrees Fahrenheit or 0 degrees Celsius to 100 degrees Celsius, the Earth allows the liquids to be, so when I say the Earth, I mean when those temperatures allow for liquid form of water. And we need to drink water. We don't breathe water in as a water vapor, and we don't, I guess you could eat it as a solid, as an ice cube, but it's very important that we actually have water to drink for organisms to live. Another benefit is, if you look at the moon, you can see, and look in the sky, you can see there's huge craters. We have craters on Earth, but the meteoroids that strike down on the Earth's surface, most of them get burnt up in the atmosphere through friction and heat. So the atmosphere protects Earth from dangerous radiation from the sun and from the meteoroids, which are chunks of solids. Now let's look at what gases we have. 78% of the gases is nitrogen. Oxygen represents another about 21%. Then you have argon, about 0.9%. So carbon dioxide, even though we speak about it so much, is 0.039%. Now that number might be increasing or decreasing. So these are all relative numbers. but it's not even 1% not even close to 1% of the gases in the air. And then we have these other trace gases like helium, methane, krypton, and hydrogen. So here's a chart here again looking at it, and this gives us some numbers. You'll need this chart later on to answer some of the Google form questions that I posted for you. So what do we have here? The reason why things burn, I lost my flame here, but there's a flame, is that because the air has oxygen. Oxygen is one of the key components to allowing fuel to burn. And we're looking over here at the greenhouse effect, which is basically, here's our atmosphere trapping the heat. Even if some of it does escape it back into space, but most of it keeps us nice and toasty. So here's some of the gases. Nitrogen is called N2 because that means there's 2 atoms of nitrogen. Nitrogen is a gas form, and it needs to be extremely cold to become a solid. And the liquid state, well, we will not see in the temperatures that exist on Earth. Nitrogen makes up 78% of the atmosphere. Oxygen is the second most abundant. Now, this is a key word here. I was talking to Mr. Coburn the other day that abundant, it seems like students always forget that. But what the word abundant means, it means a lot. So it's the second most abundant gas in the air. Plants and animals take oxygen directly from the air and use it to release oxygen into a usable form. Oxygen, like I was saying before, allows fire to burn. Key point here is we can't have life without oxygen. Carbon dioxide is present, but only in less than 0.5%. Plants need it to survive. We breathe it out and they breathe it in. Any type of fuel that burns, we talk fossil fuels, wood, coal, anything, that's what burning fuels produce carbon dioxide. We were talking about water vapor before. Water vapor usually gives us a humidity in the air. The more water vapor, the more humid it is. Steam is not the same thing. So here's an important thing. The ozone layer is extremely important. It's about 20 kilometers to 30 kilometers in the altitude above the Earth's surface. It shields us from the harmful UV radiation. How it does this is by absorbing the UV energy, and it turns it into heat. So it actually, most of the energy that's from UV light, even though we get burnt when we're out in the sun, but if the ozone layer wasn't there, you get burnt extremely fast. This is so why it actually warms up in the stratosphere, and sometimes how it's formed is when lightning goes through the air, you might see that sweet smell in the air. That's ozone. It's actually 3 oxygen molecules. I'm not going to go into detail about the air pollution right now. We'll talk about it another time. Later on, if you could click this link, and that link will bring you to the different layers of the atmosphere. I'm going to briefly explain them to you, but that'll help you with the Google Forms. So here's what we're looking at, a side profile. Now looking down, so it seems like the layer of the atmosphere, I was telling you it's thin, it looks pretty thick here. And this is not even the top of it. So as I go up in the air, where we live, this is called the troposphere. Even the top of Mount Everest, which is one of the tallest mountain in the world, it doesn't even get outside the troposphere. It's the next layer, which is called the stratosphere. So all the clouds, water vapor, weather conditions, it all occurs in the troposphere. Notice how the planes and the commercial jets, if you ever notice that they always climb to a certain height. What you're going is about a little higher than 11 kilometers. And the reason why is because it's a lot easier for planes to fly over the storms than through it. And that's another reason why landing and taking off is usually the most dangerous time for commercial jets if you're ever flying on a plane. Because most of the time, once you're up above the storms, there's not as much that can happen. There are planes that actually will fly over a hurricane, and they can look down, they can see the eye of the storm because they're above the storm. And all the storms happen in a troposphere. So the variability of every layer of the atmosphere is very predictable, except for the troposphere, because of the water vapor and the changes in temperature and the wind that occurs there. So we can see the ozone layer is right here in about 20-30 kilometers. This is where this is actually where the temperature gets a little warmer. Here's a weather balloon, just goes a little bit over this. I'm gonna show you a cool video tomorrow on this stuff. So How are these layers decided? Now, if we take a thermometer, we can actually see that there's temperature. And if you notice that at every point with dotted lines, that actually begins a new layer. As soon as the temperature changes, you have a new layer of the atmosphere. Something like a stop sign, somebody's holding it up there and saying, oh, new layer. The new layer is where the temperature changes. So, and when I say the temperature changes, because the temperature constantly changes, so let me redefine what I was saying. It means instead of decreasing, so we can see here is going from 20 degrees Celsius to about roughly negative 60 degrees Celsius. So as you climb up a mountain, it gets colder and colder, and you need to bundle up more and more, and that's why there's a snow cap over here. But as soon as you hit the stratosphere, the temperature actually starts to increase again. That's because also you got the ozone layer, and you got these other gases. So, and also the fact that the cold air is more dense, so it sinks, and in hot air actually rises, so it floats. So the temperatures over here are more dictated, where the temperature is increasing, and I'll show you the next diagram, in a stratosphere. So it goes from cold to really warm. And so what does the warm mean exactly? This thing's right here is in your way. Let me see if I get this out of the way here. I guess I can't drag this. I thought I was going to be able to drag this. But, oh, there it is. Okay, so, let me see. Okay, that's what I was looking for. Every time I pull this up, this is coming back up. All right, so let's look at this here. So here we have this. This is the temperature in the different layers of the atmosphere. So we can see over here, this is about 20 degrees Celsius to 23. This is about room temperature. Now, this is different depending on what altitude you're on, what latitude. So just say in general, we're just going to pick a point. Then you can see it keeps on decreasing. This first layer is a troposphere. It's a layer nearest to the Earth. All the weather happens here. More than half of all air in total mass is right here. So almost half of the mass of every gas molecule, because all the gravity and the densities pull, and well, I should say the density here is the greatest, but the gravity is pulling the molecules. They're putting all this pressure of the air to pull the molecules close together. And again, like I said before, the temperature and the weather conditions are located here. Then, as we get to the next layer, which is the stratosphere, we can see where in the ozone layer is here. The temperature goes up with the altitude. Most jets fly in the stratosphere. The mesosphere is where the temperature drops instead. So now it goes from about 50 kilometers. This is where you're in the mesosphere. It starts to drop, and it drops to roughly 80. Looking about, this is going up by tens, so 60, 70, 80, roughly about 90. Now, this is not exact temperatures, but this is based off this graph. So about negative 90 degrees Celsius. So the mesosphere actually decreases. And then once we get to something called the thermosphere, which represents heat, the temperature starts to go up again. And it's at its hottest point, and it's the hottest layer. So, let's look at these questions here for you. You'll have questions that are based on this diagram. Okay, let me just get out of here.